guys, welcome back. Today we'll be starting our new chapter, which will be chapter 9. So I really hope you were paying attention during chapter 8 because chapter 9 sort of piggybacks off of what we learned in chapter 8. Today we'll be talking about what rational numbers are and how to use them on a number line. So let's go ahead and get started. What are rational numbers? I want you to copy this into your notebook, ask yourself the question, and then answer. Rational numbers are numbers that can be written in form a over b, or negative a over b, where a is a whole number and b is a positive whole number. Okay? So, also, rational numbers include all integers. Okay? You want to copy this one down too because you need to know that. So rational numbers are fractions and decimals, positive whole numbers, negative whole numbers, and zero. Okay? So I'm going to give you some examples of some rational numbers. Write these down as well. One example can be 2 or 2 over 1 or 2.0. Those are all rational numbers. Another example will be negative 2, negative 2 over 1, or negative 2.0. Okay? You can also write 1/2 as a rational number. So what we'll be talking about mostly today is how, if you are given a fraction, where would that be located on a number line? How can you fully understand what that fraction represents? Okay? So if you're still copying this down, go ahead and finish that up, and then push play whenever you feel like you've got everything down. Okay, this is a think about it, so you do not have to copy it down. The Skateboard Club's exacting executive manager creates a new scoring system for the boarders. The boarders said the system is suspect because none of our scores land on a number. Do you agree with the boarders? What could their scores be? Okay. If you're watching this video with a neighbor, you can go ahead and pause the video and talk about what you think about the boarders and what you think about their opinion. Do you agree with them? Do you disagree with them? All right, pause the video while you talk that over. All right, so here's something that we're going to walk through together. You do not have to copy this one down. I just need your full attention. Okay? This will be on the homework. This will be on the test. So pay attention. Name the locations of each point as both a decimal, as a fraction, or a mixed number. Then name the opposite of each point and position each opposite's points on the number line. Alright, so there's a lot of steps to this problem, so we're going to have to go one step at a time. But before we start solving this problem, we have to break something down real quick. And that is the actual number line itself. Okay? If you look at between 0 and 1, how many parts make up one whole? This is what we're going to have to really focus on when we're talking about rational numbers. Well, you can see right here, 1, 2, 3, 4 parts make one whole. So if you were to have a whole number, you would have 4 out of the 4 parts. Okay? We know that in our denominator of a fraction, it represents how many pieces you need, and the numerator represents how many pieces you have. Okay? I'm going to leave that little key right there for us to kind of go off of. Okay? So first, let's solve for A. All right, the answer here on the side. A equals. Now, we see that the A is on the left side of the 0, so we know it's going to be a negative number. but how negative is it? All right, we have to figure out how many whole numbers away from 0 do we pass. Okay, so let's use a blue. We'll match the A bubble. So you start at 0 just like normal, and we pass -1, we pass -2, and we pass -3. We don't pass -4, so we know that -3 would be the whole number. But this is not exactly -3 spaces away from 0. There's -3 and a fraction. Alright? You can look at it and see, well, you can look at it and locate where the dot is, but I'm showing you how to break it down. Between the 3 and the 4, the A is 1, 2 out of 4 spaces away from the 3. Okay? So A is -3 2/4. Now, when we have our little school pizzas, they have 4 pieces. If you eat 2 out of the 4 pieces, you've eaten 1/2. So A equals -3 1/2. Okay? Now that we know what it looks like as a mixed number, we then have to figure out what is it going to look like as a decimal. Well, again, we know that our whole number is -3, so that's going to stay our whole number. But how much is 1/4 worth as a decimal? Now, if you remember in our section, I think it was chapter 4 or chapter 5, we turned fractions into decimals. Okay? When we're doing that, we're turning it into a division problem. So our denominator goes outside of our division table. Our denominator is our divisor. And our numerator is our dividend. 4 goes into 10 2 times, which is 8. Bring it down. 4 goes into 20 5 times. So 1/4 equals 25. Well, what if we had 2/4 or 1/2? Well, we know that half or 2/4 of a dollar or half a dollar would be 50 cents. So it's going to be 3.5 or 3.50. Okay? So we found a decimal. We found the fraction or mixed number. Okay? Now we have to figure out where the opposite of -A or -3.5 would be located on a number line. And I think I already plotted that point a minute ago while I was thinking, and so that will be located right here on the number line. Okay. I'm going to go ahead and erase everything we have here. Let's move on to finding part B. Okay. So again, first you want to see how many wholes the number is away from 0. Well, if you look at point B, you can see that you do not pass a whole number. So this will not be a mixed number. It will be let's change the color of this. It'll be a fraction instead. So B will equal, since it's going to the to the left of 0, it'll be a negative number. Alright? So since it's not a whole amount away, we have to figure out how many parts it is away. So start at your 0. 1, 2, 3. B is located three parts away from the 0. And earlier we found that between 0 and a whole number, or any whole number, you have to have 4 places to move on to the next. So our denominator is still going to be 4. 3/4 cannot be reduced anymore, but it can be turned into a decimal. Well, we know that if you have a denominator of 4, it represents 0.25. So if you have 3.25s, you would have 0 and 75 hundredths. 3/4, the same thing. Now we have to plot the opposite of B. Well, the opposite sign would be a positive sign, so a positive 3/4 would be to the right of 0. 1, 2, 3. Okay? Now the last one we're going to look at together will be C. So start at your 0. Is it going left or right? Well, it's going right, so we know it's going to be a positive number. I don't have purple, so we're going to go with green. So we will not use a negative sign when we're finding C. How many whole numbers does C pass? Well, C passes 1, so we know that we're going to have a mixed number now. Again, we know that our denominator is going to be 4 because we need 4 pieces to make a whole. How many fourths do we go over from 1 after we passed 1? Just 1/4. So the correct answer for C is 1 1/4. Now, how do you turn 1 1/4 into a decimal? Well, we know that the 1 is going to stay the same. Our whole number will not change. And earlier we found that 1/4, 1/4 is the same as 25. Alright, so the answer for C is 1 1/4 or 1.25, or also said 1 25/100. Okay? I hope that kind of is clear to you guys because you'll be doing this next part. Alright, so let's look at this one together. Find the opposite of the rational number represented by the point n. Okay, again, before we find the opposite, before we do anything, we need to figure out how many parts make up one whole in this situation. Alright, so let's count together. 1, 2, 3, 4, 5, 6, 7, 8. 8 parts. Okay? Our denominator is going to be 8. The numerator is going to tell you how many parts you have. Okay? So, like we did last time, you're going to start at 0, and you're going to count how many whole numbers away from 0 you move. 1, 2. We're trying to find point n, and as you can see, point n is not a whole 3 points away from 0, so we know our whole number is going to be 2. Now we have to figure out how many parts point n is away from 2. So let's check that out. We have 1, whoops, my pen's not working. Please work, pen. We have 1, 2, 3, 4, 5, 6, 7. So our numerator is going to be 7. So the distance that point n is from 0 is 2 7/8. So when we reflect this across the number line, or find the opposite, we need to start at 0 and go opposite 2 7/8. So we'll be doing negative. Okay? So again, you count how many whole numbers first. 1, 2. Then how many parts? 1, 2, 3, 4, 5, 6, 7. Alright, so our new spot is over here, very close to the -3. Alright? Stop. Okay, copy this problem into your notebook. In a checking account, a debit represents a decrease in the amount of balance, and the credit represents the increase. Which rational number or numbers is represented with a debit? Copy on your answer. See you tomorrow.